Common meta-argument pitfalls. Meta-arguments do not change the AWS API itself. They change how Terraform builds, orders, and tracks objects in its dependency graph before provider operations run. The official resource syntax shows count for each depends on provider and lifecycle as language-level controls attached to a resource block, not as AWS-specific arguments. That distinction matters because most beginner mistakes are graph mistakes first and cloud mistakes second. Count creates instances by numeric index. Terraform identifies them as index 0, 1, and 2, and so on. The pitfall starts when a list changes shape. If you remove the first element, every later index shifts, so Terraform can interpret unchanged real infrastructure as different instances at new addresses. The docs say count is best for nearly identical instances, while for each is better when instances need distinct values that are not naturally tied to an integer. For each reduces address churn because each instance is tied to a key, not a position. If the DB entry stays in the map, AWS SSM parameter.config index key DB keeps the same address even when other keys are added or removed. The second pitfall is feeding for each a value that is not known before apply. The docs state that a for each key must be known before remote operations begin, and Terraform rejects sensitive values or unknown post-apply values because those keys become part of the instance identity shown in plan output. Depends on exists for dependencies Terraform cannot infer from expressions alone. That is its correct use. The common pitfall is treating it like a universal safety switch. The docs explicitly say to use depends on as a last resort because it can make plans more conservative and cause more values to become known after apply, especially at module scope. The mechanism is simple. A broad manual dependency removes Terraform's ability to reason about which specific upstream value matters, so planning becomes less precise. Ignore changes does not freeze real infrastructure. It tells Terraform to stop planning updates for selected attributes. That is useful when an external controller owns a field, but it becomes dangerous when used to silence noisy diffs without understanding the source. The lifecycle reference shows ignore changes as an operational rule, not a compliance feature. If you ignore a security-relevant attribute, Terraform stops acting as a reliable alarm for that field. On a submarine, the most dangerous fault is often the one the instrument panel no longer reports clearly. Silence feels stable right before it becomes surprise. Ignored changes can create the same illusion in infrastructure. A clear plan is not proof of a safe system. It may only prove that you muted the sensor. Prevent destroy blocks plans that would destroy a resource, but it does not solve the root cause of replacement pressure. If a configuration change still requires replacement, the plan fails instead of proceeding. That means prevent destroy is a brake pedal, not a steering wheel. The lifecycle doc describes it as rejecting plans to destroy the resource. The beginner pitfall is enabling it and assuming the architecture is now safe to refactor. Create before destroy has a different failure mode. It changes operation order, but only when the remote system can support overlap. Names, quotas, uniqueness rules, and provider constraints can still block parallel replacement. The rule changes sequence, not physics. A safer plan is to combine meta arguments with explicit validation. The lifecycle reference states that precondition runs before argument evaluation completes for the resource and can be evaluated per instance after count or for each expansion. That gives you a way to stop bad graph decisions early with a human readable message. The pitfall is waiting until apply failure or cloud side rejection to discover that a rule was invalid.